Now we go to the next section, talking about functions. This is like 2 point, I think it's 2.3 in your book. A function is a rule. This is the definition of a function. A function is a rule that assigns to each element in the domain, which is this, one and only one element in a set B, which is the range, right? So you have a domain, you have a range. So here's a, if the domain, the value in the domain is 1, the value in the range would be -1. If it is 3, it would be -6. If it is 4, it would be a 1. Okay? Assigns to each element in the domain one and only one element in the set B. In other words, you cannot have, if x is equal to 1, well, this would be either 1 or it would be either -1 or a +1. More than one value. We're going to see this graphically and use an example. It would become clearer in a moment. By the way, when you write a function, you use f of x. F of x. That means a function of x, right? So y equal 3x squared plus 2 is a function with values of x as the domain and the value of y as the range of the function. So for different value of x, you get a value for y. We write f of x in place of y, and we read it as f of x, not f multiplied by x, but f of x equal 3x squared plus 2. Okay? Now, one point, x here is called the independent variable, and f of x would be the dependent variable. That means the value of f of x or y, the value of f of x or y depends on the value of x. When x fluctuates, that will cause y to fluctuate. When x changes its value, the f of x or y will change its value. So let's look at this f of x. We're going to evaluate a function. We're going to evaluate the function. That means we're going to give a value in the domain of a function and figure out what the range is. So in this case, for a specific x value, what is f of x or what is y? So an example, if f of x is equal to 3x squared plus 2, find f of minus 2. So f of minus 2 means in place of x, you put minus 2. So it would be 3 times minus 2 squared. Don't forget there is a plus 2. So that would be 3 minus 2 squared is 4 plus 2. That means 3 times 4 is 12 plus 2. 12 plus 2 is 14. Right? So we evaluated this function. At x of minus 2. We evaluated at 0. So f of 0. That means in place of x now I put 0. So it would be 3 times 0 squared plus 2. 3 times 0 squared is 0 plus 2. 3 times 0 is 0 plus 2. That is equal to 2. So f of 0, evaluating this function at 0, would give you a range of 2. The value of y, or the value of the function, would be equal to 2. Next, evaluate the function at b plus 1. F of b plus 1. Now again, it means in place of h, we put b plus 1. So it would be 3 times b plus 1 squared plus 2 equal 3. First, I have to raise this to this power. B plus 1 squared, we know from the past, it would be b squared plus 2b plus 1. That take care of this, and there is a plus 2 equal to, now multiply 3 by this, it would be 3b squared plus 6b plus 3 plus 3 times 2 is 6. So 3b squared plus 6b plus 9. If you want, you can factor out the 3, I suppose. So the b squared plus 2b, plus 2b plus 3. Okay, that is evaluating a function at different points, at different value of x in these cases. Let's get rid of these. And we know one answer was 14. I'm going to keep those, so hopefully they would not ride over my answers. So the second answer was 2. And the third answer is either this or the one at the bottom. Let's just keep both. So f of minus 2, I did the same thing I did and came up with 14, which is the same thing I did. Right? Just plug in numbers. That's all it is. Evaluating a function is just plug in a number for x into your function. Plug in minus 2. The next one, f of 0, end up being 2. There is 2. You plug in 0 for that. Next one, f of b plus 1, you plug in b plus 1 in place of h, which is what we did. Well, they're made of a mess. Three b squared. Did I make a mistake? I probably made a mistake. It should be a plus 5, not a plus 9. My bad. 3 times 1 is 3, and then the 3 plus 2 should be 5. So theirs is correct this time. I was surprised when I saw you could factor it, because normally you should not be able to factor it. Okay? Now, the domain of a function. Sometimes the domain of a function is restricted. In a lot of cases, the domain of function is any value for x between minus infinity and plus infinity. But sometimes over some value of the some value for x, some value for the domain, the function would not be defined. The function would not be defined, right? It would be undefined, right? And these normally happen when you have a square root, or your function is in the form of a square root, or your function is in the form of rational expression, something divided by something else, right? A polynomial divided by another polynomial. Let's look at this example here. First, the domain of a function is the set of values of x for which f of x is a real number, right? F of x should be a real number. And remember, plus infinity, minus infinity are not real number. Okay, find the domain of f of x equal to 2x divided by 3x minus 1. Again, as a rational expression, you have to be careful. Since you have 3x minus 1 in the denominator for this function, right? If 3x minus 1 is equal to 0, that means something divided by 0, and anything divided by 0 is undefined. Anything divided by 0 is undefined. So that would be exception. So the domain of this function is anything from minus infinity to plus infinity except the value that makes the denominator 0. So what makes the denominator 0? I solved the denominator for 0. So 3x minus 1 equals 0. That means 3x equal to 1. That means x is equal to 1/3. So for a value of x equal 1/3, the denominator would become 0, and something divided by 0 is undefined. So we say the domain of this function is anything from minus infinity all the way to 1/3, except for 1/3, so I put parentheses, right? Or, again, anything from 1/3, except for 1/3, all the way to infinity. So in this, the only thing I'm excluding is x equal 1/3. So x equal 1/3 would not be part of the domain of this function. The domain of this function would be minus infinity, any number, any real number from minus infinity to 1/3, not including 1/3, and from 1/3 to plus infinity, not including 1/3. So let's look at this, what they have done. Since the division by 0 is undefined, we must have 3x minus 1 not equal 0. So what makes 3x minus 1 0 should be excluded. So x should not be equal to 1/3. Using the interval notation, we express this by writing the domain of this function from minus infinity to 1/3 with parentheses, which means not included 1/3, and from 1/3 to infinity, not including 1/3 again. So the only thing we are excluding is from range of real numbers from minus infinity to plus infinity. The only thing excluded is 1/3. That's what this one shows here. That is the domain of a function. As I said, if you have square root, or for that matter, if you have an even root in your function, now you have to be careful. An even root, since you cannot take the even root of a negative number, that would be excluded from whatever from minus infinity to plus infinity is. So here it says find the domain of f of x equals square root of 7x plus 5, right? Now 7x plus 5 cannot be negative. So you say 7x plus 5 should be greater than or equal to 0 in order for the value of this function to be a real number. So that means 7x has to be greater than or equal to minus 5. That means x has to be greater than or equal to minus 5 divided by 7. So on the number line, here is infinity, here is minus infinity. here is 0, right? Minus 5, 7 is less than 0, but not exactly minus 1. So somewhere, let's say somewhere here, right? I'm sorry, greater than or equal to minus 5, 7. So that means it is from here. Let's say this is minus 5, 7 to the right, right? Greater than. Okay, so such as 0. 0 is part of the answer. 0 is part of the answer. And you can see if you plug in for x0, if x is equal to 0, then you have f of 0 equal square root of 7 times 0 plus 5, which would be equal to square root of 5. Well, it's a positive number. I can deal with it. But anything less than minus 5, 7 is not part of the answer, right? Let's say it is minus 7. Minus 7. So here would be f of minus 7 equals square root of 7 times minus 7 plus 5. That would be square root of 7 times minus 7 is minus 49 plus 5. It would be equal to square root of minus 44, right? You cannot take the square root of a negative number. So that is not part of the answer. So the answer is anything greater than or equal to minus 5, 7 would satisfy the domain of this function. So we have excluded part of the real numbers out of the domain of this function. So again, as usual, we're going to get rid of the answer I have here and see how they explain in the book on the slide the answer. Okay, find the domain of this. Since the square root of a negative number is undefined, we must have whatever you have under the square root sign, you must have that positive, greater than or equal to 0. 7x plus 5 greater than or equal to 0. Now you solve it. That means x should be greater than or equal to minus 5 over 7. And using the interval notation, you express this as minus 5, 7 to positive infinity with, well, it actually has parentheses here. Again, something not right. Something not right. Since it is equal to, it actually has to be a bracket here. Okay. Domain of a function. Now, going to graph part of a function. Graph of a function. Graph of a function is a set of all points x and y with the coordinates of x and y such that x is in the domain of f and y equal f of x, right? So number one, x value has to be part of the domain, and the value of y on the vertical axis would be f of that x, right? So you plug in for x, whatever that value is, as long as the value is part of the domain, and you get the value for y, and then you can graph it, okay? So given the graph of y equal f of x, it's just assuming some graph like this, find f of 1. Graphically, it wants you to find f of 1. Well, f of 1 means x is 1, so you come from 1 up, and you come across and read it, right? So f of 1 is right here, whatever this number is f of 1. The number on the range, the number on the vertical axis is your f of 1. Equal to 2. Yeah, 1 and 2. Okay? That's what that point is. Sometimes a function can be defined differently for different values of x, for different values in its domain, right? It would be defined differently. So here's an example. It says f of x equal x plus 1 if x is negative. If x is negative, is h of x plus 1 a linear function? If x is positive or 0, it would be h squared plus 1. So it would be nonlinear. If x is negative, that means in this area, anything in this area, right, to the left of this 0, anything in this area, in this general area, right, let me use this. Anything here would have h sub negative. So for that, it would be h plus 1. The function would be h plus 1. For example, if x is, let's say these are 1, 2, 3, 4, right? If x is equal to 4, right? Or minus 4, I'm sorry. If x is equal to minus 4, I have to use this function. So f of minus 4 would be equal to minus 4 plus 1, which is equal to minus 3. So it would be minus 3. This point, right? All the way to x being 0. All the way to x being 0. As x come closer to 0, this would get, let's say x is 0, this would get close to 1. So it would go something like this, as a straight line. And beyond that, when x is positive above 0, then you're dealing with this. Let's say x is equal to 1. So f of 1 equal 1 squared plus 1, which would be equal to 2. So if this is 1, it would be here. F of 2 would be equal to 2 squared plus 1. That is equal to 5. 2 would be 5. Probably be up here. When f is 3, when x is 3, that would be 3 squared plus 1. That would be equal to 10, right? Somewhere up here. So from beyond this point, it's going to be nonlinear. It's going to be a curve going up like that. So a function is defined differently for different values for x. In this case, between 0 is a cutoff point. So let's see how they graph this. Again, it is, you notice when x is negative, one more time, when x is negative, it is linear function. When x is 0 or positive, it's a nonlinear function. It's a curve. So that's what you should expect to see. So that is for x being negative all the way to this point. You see a line, because it is x plus 1, a line. And beyond that, it's going to be a curve. Right? Sometimes a function can have 3 or 4 or 5 pieces, so it would be defined for different values of x. You will have those examples in your book. Now, when you have a function, a test of a relationship between y and x being a function, one way to test it is a vertical line test, right? If you run a vertical line on the Cartesian coordinate, it should cut your curve only in one place. If it is more than one place, then you don't have a function. So look at this function on the left. If I draw bunches of vertical line, as many vertical line as I want, each one of these vertical line is going to cut the function only at one point. This first vertical line is cutting it here, the second vertical line is cutting it here, the third one is cutting it here, 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 only one point. In contrast, if I do the same thing to this picture on the right-hand side, to this picture, right? Right? Well, this first one is cutting the curve at one point, this one at one point, this one at one point, this one at one point. Pay attention to this one, to this line. It's cutting the function here, the same line, the same vertical line. It's cutting it here, and it's cutting it here, right? It's cutting the curve in three places, right? So that says this here, this curve here, not a function. That is not a function, right? This is a vertical line test. Okay, it's not. It doesn't show a functional relationship between x and y. X, again, normally we call it the independent variable and y the dependent variable, or x is an input and y is an output. So I probably have done this a little neater than I have. Let's look at that too. These are the vertical lines that went through, all of them cutting the curve at one point. That is a function. This blue curve represents a function. This one, cutting this at 3 points, more than one, not a function. That is not a functional relationship. What this means, by the way, what this means is for an x value, it means for the x value, for x value of this much, whatever that number is, y can be either this or this or this, right? Remember at the beginning when they talked about domain and the range, right? You should have only one value in the range. For a given value in the domain, you only have one value in the range. Now here, for a given value in the domain, which is the x value, you get 3 different values for y. So that is unacceptable. That makes this not a function. The graph is crossed more than once, so not a function.